Good afternoon and welcome to Mr. Mickleborough's Maths World. This is the way it is. Okay, I've got a little reciprocal function here, or a function, sorry, that we want to find the graph of. And really, the essential features we want to identify are as follows. The asymptotes, of which there will be two. There will be a vertical and a horizontal. And this one will have an x-intercept and it will have a y-intercept as well. So they're quite easy to find, so we'll find those. And they're the only real features of the graph we want to find. So the x-intercept and the y-intercept. Now the thing about these functions is that they're very similar to our base function, if you like, function f of x equals 1 over x. We recall that that looks like that there, and that you've got two asymptotes, a horizontal one along the x-axis and a vertical one along the y-axis, like so. This function here, in fact, as you're going to see, is just that function but shifted. In fact, I can tell you now, shifted 2 units to the left and 1 unit down. Alright? So, let's proceed along those lines. Firstly, our vertical asymptote. Well, the thing about the vertical asymptote is that it's going to occur where our denominator is equal to 0, where our denominator is equal to 0. Not where x is equal to 0, but where our denominator is. And the reason is, of course, that 1 over 0 will be undefined, and that will result in a vertical asymptote. So, we say x plus 2 equals 0, therefore x equals negative 2. Okay, as I said before, it's looking like this will be our basic hyperbola, 1 over x, shifted 2 units to the left. Now, horizontal. The mind game we play here is what happens as x gets very, very large. And what happens when x gets very large is that this rational part here is approaching 0, isn't it? 1 over an extremely large number is approaching 0. But then from 0 we want to subtract 1. So there will be a horizontal asymptote at fx equals negative 1. Okay? Alright, now the x-intercept and the y-intercept, we use the same logic that we used for straight lines, for parabolas, for cubics, etc. The x-intercept will occur when y, or in this case f of x equals 0. So that's going to occur when f of x equals 0, which is going to equal 1 over x plus 2 minus 1. First job here is to add 1 to both sides. 1 equals 1 over x plus 2. And by cross multiplication, I can just swap the x plus 2 with the 1 on the left hand side. So we get x plus 2 equals 1 over 1. Well, that's just 1, isn't it? And then we would subtract 2 from both sides. X equals minus 1. So there's a y-intercept at x, an x-intercept at x equals negative 1. The y-intercept is to be found. And let's do that now. The y-intercept, as usual, occurs where x equals 0. In fact, it's not the y-intercept, it's the f of x intercept, strictly speaking. So, that's going to occur here, which is when, now we're letting x equal 0, so it's a half minus 1. That's simply equal to negative a half. Okay, so what we've got now, fellas, is an x-intercept, f of x intercept, or y-intercept, think of it as perhaps. The vertical asymptote and the horizontal asymptote, that's all we need to sketch our graph. Okay, so let's have a go at a sketch. Now, just looking at my features, you've got negative a half, negative 1, negative 1, and negative 2. Alright, so a bit more negative over there. And what we've got, firstly, is our vertical asymptote. So we're going to make that perhaps there, like so. -2, x equals -2. That's our vertical asymptote. Our horizontal asymptote occurs where our function value is -1. So maybe along here, just label it -1. We should label 0 there. Arrow f of x, axis, x-axis, arrow, arrow, arrows everywhere at the end of every line. And now we're ready to, well, we need to plot our x-intercept, which we discovered was at x equals -1. So let's find x equals -1. It will be here. Perhaps, so -1. And the y-intercept is at -0.5. So it would be there. Now please note, you've got a plot point there, a plot point there. These will generally apply to one branch. Remember there's two branches to a hyperbola, one branch only. So it's applying to the upper branch. That means my graph is going to go like so. Alright, so maybe start there and extend it. They get very steep. Of course, the closer we get to our asymptote, and it should not touch the asymptote, either asymptote, like so. And my other branch, well, it's not going to occupy much space, like so. And there is a sketch of the function fx equals 1 over x plus 2 minus 1. Can you stop?